Okay, continuing with section 8.1. Okay, we have for the next system, okay, we have in the variables x and y, we have 9x plus 4y is equal to negative 3. And we also have 4x minus 7y is equal to 25. And we're looking at the values of x and y that will fit into both equations. And now, if you notice, we don't have automatically additive inverses where we can use the addition method right away, but we can make a quick fix adjusting the equations where we can have elimination of one variable and solving for the other. And let's say that if I were to look at solving for y, and it'll be through the process of eliminating x. So you got 9x and 4x. Now right away, 9x and 4x will not eliminate each other if you were to add, but there is multiple, both 9 and 4, where we can create a process of elimination of x through the addition method. Now the smallest number that both 9 and 4 will both go into will be 36. So I can make one of these terms 36x, and through creating elimination, I can make the other x term as negative 36x. So what I will do here is that I'll just make the 9x as a 36x. So I'll multiply this one by 4, and I'll make the 4x as a negative 36x, and I will just multiply the second equation by negative 9. And if I do this, we have 4 times 9x, so this will be 36x. 4 times 4y becomes 16y. 4 times negative 3 becomes negative 12. For the second equation, negative 9 times 4x will be negative 36x. Negative 9 times negative 7y, okay, this will be a positive 63y. And negative 9 times 25, that will be a negative 225. And if I look at combining by adding the equations together, say I have 36 and negative 36x will cancel each other out. 16y plus 63y, this will become 79y. And a negative 12 plus a negative 225, this will be a negative 237. And if I divide 79 into negative 237, well, negative 237 divided by positive 79 comes out to negative 3. So we have y at negative 3. And I can plug in this result into y for either equation and solve for x. And we'll go with the second equation. So if I have 4x minus 7y equal to 25, and plugging in negative 3 for y. So we're going to have 4x minus 7 times negative 3 is equal to 25. So you have 4x, and what's going to be plus 21 is equal to 25. So we have 4x is equal to 4, and so we have the x is equal to 1. So just looking at what we have in the overall picture. So we have an x at 1, y at negative 3. So we have 9 plus 4 times negative 3, so it'll be 9 plus negative 12 equals negative 3. 4 times 1 is 4. Negative 7 times negative 3 becomes, in this case, positive 21. So you have 4 plus 21 is equal to 25. Okay, now for what we have in the case of identifying the type of solution as well as maybe the solution itself. And we have for item number 5, okay, and we have a graph of 2 lines that are intersecting each other, and now we have with the point of intersection, and we have for the location, okay, let's say we have it negative 2, 2. And now for the graphs, okay, now we have intersection at 1 point, intersection at one point means that we have one solution. And we have intersection at one point, we have one solution, and the type of system we have is going to be a consistent, independent solution. Okay, meaning they have one function, or say one expression has its own graph, the other one has its own graph, so you have consistent, independent, and we have intersection at one point, and again we have in this case we have a unique solution. And this is whereupon we have xy is equal to -2, 2. So x at -2 and y is going to be at 2. All right. Now, for what we have for the next part, okay, if you have we have with the graph running end to end, where we have L1 and L2, same graph. If you have the same graph, that means, okay, you're going to have for the type of system, that's going to be a consistent dependent. You have a consistent dependent solution. And also, if you have the same graph, you're also having, as a result, not just one solution, but infinitely many solutions. And now in the case of the third graph, okay, if you have, say for L1 and L2, you have parallel lines. And with parallel lines, you have no intersection point. And that means we have no solution. And a system that has no solution is going to be regarded as inconsistent. Now, in the case of what we have with our two systems in problem 6, for the first system of equations, now we have that x plus 2y is equal to 4. And we have negative x minus 2y is equal to 4. And for this system, now we have additive inverses for the x and the y terms. And if I add the equations together, you have x minus x is 0, 2y minus 2y is 0. However, 4 plus 4 is 8. And that is going to be false. So what this means is that for this system, okay, there is no solution. And now the graphs would be lines running parallel. So you have no solution. So you have an inconsistent system. And for what we have for the next system, we have negative x minus 2y is equal to negative 8. And we have the x plus 2y is equal to positive 8. And again, we have additive inverses And if I add what I have here, say I have 0 plus 0 is equal to 0. And what this means, okay, we have a true outcome, and the x and the y terms canceled out, so that means that for what we have here, we have infinitely many solutions. And this is in reference to a system that is both consistent and dependent. And in terms of satisfying any equation, you can say that we have y is equal to a set of all real numbers. And if I were to put as an interval, again, we have for all real numbers, again, you have in parentheses, you have inside the lower and the upper limits respectively at negative and positive infinity.